Futures research is a set of distinct research approaches in predicting and anticipating future conditions. In line with UPOU's articulation of the University of the Future, the series of talks in Research Conversations 2020 features experts in scenario building, multivariate trends analysis, simulation approaches, decision support systems, and modeling. Through this forum, we hope to enlighten and capacitate faculty members and researchers, and in the process, enrich our research outputs.
A pleasant day to everyone. Welcome to another Research Conversations 2020 Futures Research Series webinar brought to you by the UP Open University Office of the Vice Chancellor for Academic Affairs in collaboration with the Faculty of Information and Communication Studies. I am Jessica Tapia from UPOU OVCAA, and I will be your moderator for today. I would like to thank everyone for joining us today. We are streaming live on Facebook, YouTube, and UPOU Network's website. For those of you who will be having questions about our topic today, you may post all your questions in the chat room or the comment section of the platform of which you are using to view this webinar. All questions will be addressed later during the question and answer discussion with our speakers. Also, in case we cannot accommodate all your questions, you may leave your email address so we can send you the answer via email. Moreover, a certificate of participation will be issued in this webinar. Just make sure to answer the evaluation that will be available after this webinar. Now, let me call on of the Faculty of Information and Communication Studies to introduce our topic and speaker for today's Futures Research webinar series.
Thanks, Jessica. Good afternoon, everyone. It is my great pleasure to introduce my colleague and friend, Angelo Vermeulen. Angelo is a wildly accomplished individual. He's a space systems researcher, a biologist, artist, futurist. He's actually working on his second PhD right now at Delft University of Technology, where he's researching bio-inspired concepts for interstellar exploration. I first met Angelo about 12 years ago. I think that's about right. When he worked on his first project in the Philippines, and I was co-leading the project with him, actually at the Open University at UPOU. And since then, we've been working on a number of different projects, exciting, interesting projects, I think some of which he'll be talking about today. Angelo is a TED Senior Fellow, and he's done an innumerable variety of things. He has been a NASA crew commander for Mars simulation in Hawaii. He co-founded SEEDS, which stands for Space Ecology's Art Design, an international network of artists, scientists, engineers, and activists, quite a few of whom are actually based in the Philippines and actually work at the UP Open University. He has published over 40 papers and book chapters, has talked extensively all over the world. And today he'll be talking on the subject of post-planetary design, reimagining paradigms of the future. Angelo?
All right. Well, let me get these slides working. Okay. And then we're going to swap this one. Okay. Can you see my slides? Can you see my
quite
slides? If you can just confirm that you can
Not
see my
quite
slide.
yet.
Okay. Because I'm presenting, of course. Just a second. I need Here we are. And now I'm going to swap. There you go. Now you can see it, right?
Yeah.
All right. Well, good afternoon, everybody. Afternoon in the Philippines. Thanks, Diego, for this warm welcome. Indeed, I have been to the Philippines many times. And so these are all, I mean, I consider many of you here colleagues at UPOU. And I feel very honored to give the last presentation in this series of the year. And my particular focus is going to be on post-planetary design as a tool to reimagine paradigms of the future. Diego already mentioned it. I actually co-founded a collective, a network, which is called Space Ecologies Art and Design. And this is actually the platform that I'm operating from. Space Ecologies Art and Design is a collective of people with very different backgrounds. We basically bring art and science together. We have members, engineers, scientists, artists, designers, all coming together. And our main goal is really to re-envision the future. It's not just space. I mean, we use space in our name, but we're broadly interested in rethinking the future, and this through a combined approach of a combined approach of hands-on experimentation and theoretical reflection. And so we have a number of projects that we worked on over the past 2 years, some of which were actually developed in the Philippines. And there are basically 3 focus points that we use in SEEDS. And the first one is that we are really focused on pre-rehearsing the future and decolonizing our imagination. This is really something we're all very interested in, because if we're all embedded with these paradigms that actually tell us how the future will and should evolve, and it's not easy to break away from them. It's actually very difficult to gauge the future, as we all know. And if you look at history, usually when people were imagining the future, they were often very off. So there is something in our imagination that seems to sometimes block us from properly thinking things through. And it's interesting to try and circumvent that. And one of the approaches we use for this is embracing a hacking ethos. We really hacking in a very broad sense, of course, not just software hacking, for example. That's not really what we're talking about here, but rather in the beauty about hacking is that you look at something and you open it up and you look at it from a different perspective and at different possibilities of it. And I think that's where this hacking ethos comes in trying to break away from entrenched paradigms. The second topic that we are really focusing on with Engines of Eternity, with Space Ecologies Art and Design, our collective, is emergent design. We're not so much interested in following or setting up blueprints, top-down blueprints that are being imposed. We're rather interested in systems that gradually develop and adjust over time. Now, why are we interested in such an approach? Well, it's almost like you could say, the opposite of colonization, if done well. It's if you have systems that actually grow and develop over time, instead of being imposed top-down, you create systems that are you can create systems that are more integrated in their own context and that are in the end more robust. And I think that's one of the reasons that we're truly interested in emergent approaches to the things that we create. And then the last focus point of SEEDS is we are a group of transdisciplinary people, so we are active in multiple disciplines. We're also cross-cultural. Like I said, there's people from the Philippines in the collective, but also people from America, Europeans, so from all corners of the world. And the way we operationalize this diversity is through co-creation. Now, when we're talking about co-creation, we're not just talking about creating together. I mean, that's a little too simplistic. the way we embrace co-creation is truly with a philosophy of enabling people to step into domains where they're not necessarily an expert, and embracing their input and valuing their input as well as all the other inputs. And so the advantage of having voices participate in particular discussions that are not necessary and they're not necessarily experts in the discussion is that they bring in, might look at things in very different ways, maybe even different than the tradition of the particular field. And I think that's really a strength of it. And so we're really embracing with of diversity, not just for increasing inclusiveness, which of course, obviously is a goal. We want the conversation about the future to be more global and inclusive, but also because through this approach of co-creation, we can increase the collective intelligence of the group that is tackling or trying to tackle a particular problem. And I'll come back to this idea of transdisciplinarity and diversity at the end of my talk. As Diego mentioned, I've been creating together with Diego and with other people from UPOU, we have been creating projects in the Philippines. And this was the first one. This was back in 2009. We created the Biomod project. It's an ongoing art project from the Seeds Collective. We worked on this for about 9 months. It was a long community project in which we developed basically the second version of this project. By now, there have been 30 versions that have been created all over the world of this particular art installation. And let me briefly introduce you to the core idea behind this installation. What we do in Biomod is really we recycle e-waste, old computers that people throw away. We open up the computers and we figure out which components are still working. And then we put those components back together into functioning computer units, after which we put together all these functioning computer units into functioning computer networks. Like I said, it's a community art project, so we engage communities to work with us. This is never done using a top-down approach in line with our philosophy, our core philosophy. So basically the only thing that happens is that whenever we go to a new location, we bring the concept, we bring the core idea of Biomod, and then local participants start shaping that particular idea. And so what is important to know is that this is not just about computers. You can see the plants living inside the structure, and that's really key in Biomod. After we build those networks, we're actually building a living ecosystem inside of the computers, inside of the computer networks that coexist with the electronics. And depending on the climate where we are, we capture the heat of the electronics, and then we use that heat the waste heat of the electronics to boost the growth of the ecosystem. But we've also been experimenting with aquaponics, with sensors, and with robotics to create multiple layers and multiple connections between the living ecosystem of plants and fish, for example, living together with all these electronics. And when the work is on display, it is actually accessible for the visitors. They can actually log into the computer network on which we usually run a multiplayer art game, and then people can engage with each other. And so what happens is that the more people engage in the computer, the more they boost the computer. So that's kind of the core idea here. More recently, actually, were organized by UPOU, and Seeds was also partnering with this. There was the Collaboratoire in Siargao, which was a on-site workshop with several people and students, participants from all over the Philippines, artists, designers, and we reflected on different aspects on rethinking the future as well. And then secondly, I also participated in the Off the Lip conference that was organized at UPOU also earlier this year. So for today, I'm going to focus on 4 topics. And this is the overview. First, I'm going to talk a bit about something that I call molecular sustainability. It's a bit of a kind of radical version of sustainability. Then I'm going to talk about the main topic of today, which is post-planetary design, and explain to you how I am embracing it and how I'm using it as a theoretical frame of reference. I'm going to talk about futures literacy, which is of course very relevant for this series. And then I'm going to conclude talking a bit about the imperative of arts and humanities when we're talking about when we're thinking about the future. Let me start with the first one. If we think about the human body, and I'm a space systems researcher, I work in the field of space. I'm an artist, but I'm also an academic. So I think about these things a lot. A human body has particular daily metabolic needs and minimal metabolic needs. It needs almost a kilogram of oxygen, a minimum of about, to keep functioning well, a minimum of about 2,700 calories of food and about 3 liters of water. These are figures, these are hard facts. If you want to keep people alive in outer space, this is something you need to take with you. Now, if we're thinking about a Mars mission, for example, and you think about there are different ways to get to Mars, and you can choose this one, which is a very efficient one, the Hohmann transfer, which would take about 35 months. If you start calculating what you need in supplies for a cruise, a lot of weight. That would be a huge spaceship. So that's not really the way forward. So you need a different approach for long-term space exploration, a different approach if we want to bring people into space beyond the International Space Station into deep space for these extended missions. Comes up here is the idea of a regenerative ecosystem. Building an ecosystem, an artificial ecosystem that actually helps in producing food for the astronauts. And the idea of a regenerative ecosystem is not new. It's been explored for a long time. For example, one of the grandfathers of space exploration, the Russian Konstantin Tsiolkovsky, was already thinking about this in the 19th century, and then in the 30s he published a book with sketches, and you can see here on the left hand some of his sketches of space-based ecosystems in which the astronauts would float. More recently, we have the massive experiment that was set up in Arizona in the US called Biosphere 2, in which people lived isolated, locked up in an artificial ecosystem to investigate how they would thrive. This was a difficult experiment. There was an artificial ecosystem. They basically tried to recreate a number of biomes from the Earth. They had a mini desert, a mini ocean, a mini savanna, etc., and then an agricultural area. Now, the thing is, if you miniaturize ecosystems, they don't necessarily operate as that ecosystem in the real world. And so what happened is that things started overgrowing. Other things, there were cockroaches and ants starting, pests broke out, basically. All the pollinating insects died off, and they started getting issues in producing enough calories to sustain the crew. They did a second shorter mission in which they resolved some of the issues, but nevertheless, just throwing together a lot of species and hoping that the whole system will balance itself out might not be the most safe option. So there are other ways to approach this, to approach a sustainable system, a sustainable, a regenerative ecosystem to keep people alive over longer periods of time. And this is such an approach that was developed by the European Space Agency. The program is called the Melissa program. And I've been collaborating with the Melissa program for a number of years now. And this is a bit of the opposite approach of what we just saw in the example of Biosphere 2 in Arizona. This is more like a minimal ecosystem. It just contains only a few organisms, and this allows for much better control. And what you can see is basically an overview of 5 compartments. The humans are considered one compartment, and then all the waste of the humans is being captured and is being gradually broken down through a sequence of 3 different bioreactors with specific microorganisms that gradually transform the waste materials of the humans into nutrients for plants. And then these plants, these crops, provide oxygen and food again for the astronauts. So it's really a fully closed system. Different components of the system are ready, but it's not a space application yet. At this point, we're talking about a large laboratory which is not ready to be shipped to space. But like I said, it's in full development. Now, there are a few consequences of what I introduced here, because I'm very aware that for some people, this might seem a little far-fetched. And I'm also aware of the fact that I'm in a privileged position to be able to talk about these things. There are people on Earth that have more, and especially what I heard from the Philippines with the recent problems with the typhoons on top of the corona pandemic. I think it's only fair to bring that up. that not everybody is in the condition to start reflecting about space-based colonies and producing food in space. Producing food on Earth might be the first and foremost concern there. But there are some interesting lessons to be drawn from this also in terms of what it means for Earth, for our life on Earth. For the first one is that what it really does, this reflection that I just tried to explain to you, is that you end up with a perspective on Earth, which you could call molecular sustainability. And molecular sustainability is really more deeply, more thoroughly thinking about sustainability from a molecular perspective. It's like every single molecule is valuable. You basically capture everything and you don't waste anything, and you make sure that everything is somehow recycled, reused. And this philosophy, of course, this perspective is really crucial in deep space, because if you're on a long voyage, everything you throw out is gone forever. There is nothing else you can grasp out there. So that's why you have to use that approach. But it's actually also an interesting approach for Earth, of course. And the thing is, we used to live in a world where we thought that, for example, the oceans and the atmosphere were endless reservoirs. So we did not really need to embrace that idea of molecular sustainability. We could be like, yeah, the molecules keep coming. We don't need to be as focused on every single molecule. But what happens now is that humanity has gotten this big and this industrious that, yes, we find plastic particles everywhere in every single spot in the ocean. And we experience climate change everywhere. We are actually contributing to the change of the atmosphere, which, for example, 100 years ago, for most people would have been very difficult to imagine. So that molecular sustainability perspective, I think, is not just useful in space, but also useful on Earth. The second thing that is mentioned here on my slide is obsolete obsolescence. And I think that's really a beautiful way to put it as well. There is no more obsolescence. And this is really the world we need to evolve to, that nothing gets wasted again, and everything, and you think about everything deeply on how it's part of a cycle and things keep coming back at you. And the superbody is an interesting consequence of these closed ecosystems, because what happens is that if you live in a closed system, which is these extreme closed systems in space, what happens is, because of course all human waste, which means solid waste and urine and sweat and CO2, is being captured, is being broken down, is being recirculated. After a number of iterations, molecules, atoms have been moving between all these different bodies. So basically, you're starting to share atoms that have been participating in bodies from all the plants, but also from your fellow astronauts. So all of you, the plants, the microbes, the astronauts, you become one superbody, basically, which is a quite interesting perspective. And I think the perspective is interesting because it shows us how we are all connected, but not just in some kind of philosophical way, but in a very physical way. And so this brings me to my second topic of my talk, post-planetary design. Now, I bumped into this concept of post-planetary design through my colleague at the Parsons, the new school in New York City, when I was working there as visiting faculty, and he gave a course which was called post-planetary design. And it is a very interesting course. I mean, it's been changed now into there is a new version of it. But the way Ed Keller approaches it is really using that idea, or using the imaginations about the future of humanity into the deep future as a tool to analyze how which paradigms we are embracing and how we can break away from those entrenched paradigms, something I talked about in the beginning when I was introducing our collective seeds. And this was really the start for me to dive deeper into it, and I've actually embraced the concept in my own way, and so I'm going to present this as well. Now, the whole idea of post-planetary design boils down to this, and I'm showing you here one of my favorite TV series, which is The Expanse. Is a good example from popular culture, which is dealing with the topic of post-planetary design, even though they don't really use that concept in this series. And The idea of post-planetary design is really, it's the stage of humanity where living on the surface of a planet is one of the options. Humanity is essentially spread out throughout different possibilities in the solar system and beyond. People are living on spaceships and space stations. People are living in mining colonies, on asteroids, on planetary surfaces. And so that's why we talk about post-planetary design. You're not just designing for planets, you're really designing for a civilization which has spread out throughout the solar system in all these different configurations. And in this particular series, it is really used as a departure point. People are living on Earth, but still on Earth, but also on Mars and in the asteroid belt. And because of increasing divergence between those different cultures, conflicts start breeding. Now, my personal work in post-planetary design is really focused on interstellar exploration. It's the stage where humans venture beyond the confines of the solar system and move into deep space, traveling towards another star. This is physically possible. We don't have the propulsion systems yet, but technically it is possible to reach nearby stars that are a couple of light years away. Now, one of the biggest challenges of interstellar exploration is dealing with the inherent uncertainty. When we're talking about interstellar exploration, it's a very challenging, obviously, it's a very challenging, how to put it, question for engineers, because you're basically, you don't really know what's going to happen. It's difficult to gauge what's going to happen during that particular trajectory. It's not like going to the moon, for example, like when the Apollo program was established, different missions went subsequently closer and closer to the moon. And it was only after a number of tries and after gradually getting closer and closer to the moon that Apollo 11 finally touched down on the surface of the moon. And there's approaches used to make sure that all the risks and contingencies can be mapped of such a journey. Now, the thing is, with interstellar exploration, you can't just gradually get deeper and deeper into interstellar space and always come back to Earth to see can be mapped of such a journey. Now, the thing is, with interstellar exploration, you can't just gradually get deeper and deeper into interstellar space and always come back to Earth to fix some problems or some issues that you did not predict. That would be a very inefficient way to perform interstellar exploration. So this is really a conundrum for engineers. How do you design a solution for a challenge that you don't fully grasp or can predict? This seems almost impossible, right? Now, we're using biology as a solution here. And so the concept we're developing is to develop a concept for a growing and evolving spacecraft, a spacecraft that is actually adaptive in a way. I'm doing this with an entire team of people. Some people are from SEEDS and some people are from Delft University of Technology. And we typically, like most of the things that we do in SEEDS as well, is to bring together multiple disciplines to tackle this complex question. And so you might wonder, how are you going to develop a growing and evolving spacecraft? Well, we're actually combining two technologies that are currently in full development. First one is asteroid mining, and the second one is 3D manufacturing in space. And so the core idea is really to use an asteroid as a starting point and to gradually mine the interior of the asteroid and to use the resulting material of the asteroid to 3D print a growing architecture, a modular architecture that gradually extends outside from the asteroid. And then the idea is also to retain part of the asteroid, of the structure of the asteroid, so the front part of the asteroid can double up as a shield and protect the structure against collisions with particles, because interstellar space will happen at relatively high speeds, and a collision with even a small particle could cause potentially a lot of damage. And space is not fully empty. Even though we talk about vacuum, there are still dust particles and smart particles in space. Now, the idea of transforming asteroids into a spacecraft, into space infrastructure, is interestingly is not new. This is definitely not something that we came up with. Here's a few examples. Dandridge McFarland Cole was one of the first engineers who started really thinking about how to transform asteroids into living worlds for humanity. But I think many of you will have seen these concepts in popular fiction, such as the Mass Effect series, for example, the game series. You have multiple examples there of asteroids that are transformed into architectures, which you can actually, in the game, you can visit. So our contribution is, of course, not this particular idea. Our contribution is more that, first of all, we're using this bio-inspired approach of, and let me see if I can show it here. We're using this bio-inspired approach of morphogenetic engineering, which is really something that the best way to explain it is using termites. It's a new field of engineering inspired by biology. And when we talk about termites, they have evolved through evolution. They have created these magnificent structures, architectural structures, which are called termite mounds. And a termite mound is essentially a cooling tower. It's a cooling tower that is constructed on top of a farm that termites maintain, a farm in which they grow fungi. So underground, there is this underground farm of fungi with a lot of young termites and larvae, fungi being grown. So as a consequence, this colony needs a lot of fresh oxygen. Now the thing is, just hot air to get that fresh oxygen, the colony would simply overheat. So there is this really interesting difficulty for termites how to bring in fresh air but keep the hot air out. And they actually developed a system for this. I'm not going to go into all the technical details, but it's about a basic, specific orientation towards the sun of the cooling tower, and then building shafts, ventilation shafts with a particular morphology that actually allows for fresh air to come in without bringing in all that hot air, or the heat without bringing in the heat. Now the thing is, the core thing here, the core message here is that this sophisticated animal engineering, this animal architecture, there is no blueprint for such a system. When termites start building a new termite mound, there is not a single master architect in the world of termites that runs around with a blueprint telling every single termite what they need to do. This termite arises through emergence. It's through the interactions of the swarm of termites that actually the structure emerges. And it's basically something you can translate into engineering using robotics. You can have swarms of robots building structures, and you're not, in this way, in morphogenetic engineering, you're not really focusing on designing the final end product. You're much more focusing on designing the properties and the rules of interaction of those different robots. So your focus of design really shifts to the agents that are actually going to build the structure that you're interested in. And the structure you're interested in is also not really fully predictable. It's basically emerging out of those interactions. So by tweaking those interactions and properties, you can tweak the final result. And this is the way we're developing our system as well. Through, of course, it's a theoretical system at this point. The spaceship is really developing because it's being built by a swarm of robots. Now, the idea we're actually extending this idea. We're not just having a swarm of robots building a structure, we're also using the concept of self-replicating automata, which is an older idea. It was first properly scientifically developed by the mathematician John von Neumann. And the idea is basically you have systems that are building something, but those systems, like robotic systems, can also build copies of themselves. So they're not building, they're not just running a task, they're also actually making sure that they bring more copies into the world that can actually help them to accomplish this task. And interestingly enough, this actually has been explored by NASA before. There's a beautiful report that was published in the 80s on how to use this concept to develop a moon factory. It's basically robots that are starting to build the moon factory, but they also use local resources to start building copies of themselves. And I was very inspired by these works, and we actually embedded this into our concept. So those robots I was just talking about that are building our spacecraft can also build copies of themselves. So I think this is really where we are bringing it into something. We're taking it out of strict imagination, and we're really transforming it into a scientific research question. And so what we're doing with our research group and Delft University of Technology is really building a hybrid computer model to explore this. We're basically building a computer model in which we can throw virtual basic spaceships into a virtual journey through space and then observe how the spaceship evolves over time, depending on the initial configuration of the spaceship, the initial conditions, but also depending on the particular chemistry of the asteroid. And this is really what we're doing, and this is really the kind of research we've been working on for a couple of years now. Now, we're using hybrid modeling without going too much into detail, but hybrid modeling is an approach in which you combine, you connect different modeling formalisms, which is very interesting because not every single phenomenon can be modeled in one particular formalism. And in this case, we're trying to combine agent-based modeling, discrete event simulation, system dynamics, and evolutionary algorithms. And each model has its own approach, and then it's all about synchronizing the clock for these different models so we can connect everything. And so this is just a visual representation of some of the experiments that I was talking about that we can run in these computer models. Imagine a particular journey through space, but then starting from the same initial conditions, except for different asteroid compositions. And so the materials in the asteroid have different physical properties and will protect the spaceship in different ways, for example. And then this will impact the evolution of the morphology of the starship. And so this is the kind of work that we're interested in. Now, if you're just investigating under which conditions you can build a sustainable and robust architecture that could bring humanity into deep space, of course, that's just part of the solution. If a spacecraft arrives at destination and everything inside is dead, well, then that was a failure, of course. So we decided to integrate a virtual ecosystem in our computer model. And for this, we're actually using the Melissa concept that I talked about before, and we actually integrate it into our hybrid modeling. As you can see here in this final overview, we start with the asteroid. The resources are used both to drive the growth of the ecosystem and the growth of the starship architecture. The architecture wears out, and so after some time, components of the architecture have to be recycled inside the system. So there's a lot of dynamics going on here in such a system. Now, true to form, we basically have been using quite a lot of visualization to really get a grasp on this concept of what an evolving space architecture could look like and how it could behave. And at a certain point, we actually transformed and we used this material to create autonomous art installations. And there have been different versions of this art installation. It's basically the focus of the art installation is mostly on, once again, questioning how we think about the future in terms of space exploration and how often biology is lacking in these visions. So we basically want to make a case for a more biological science fiction, and that's what we try to communicate through this installation. It's been displayed in different shapes in different arts institutions over the past number of years. And this brings me to the topic of futures literacy. I've repeated already a number of times, we all have these particular ideas on how the future could look like. And I think this is a classic example. If you go out in the street and you ask people how they think about deep future in space, these are often the tropes that come back. It's the tropes from series like Star Trek and Star Wars, with very particular designs of spaceships. And you can even, it's interesting to look at them, because if I look at the spacecraft from Star Trek, it is really a shape that comes from the space age, where things were very aerodynamic, which is not really something you need in deep space. And then if you look at this huge spacecraft Starship from Star Wars, you have these typical angular aesthetics that were very popular in the 70s. Even if you look at the cars from the 70s, this kind of particular angular aesthetic. So you can really see how the culture of the day actually seeps into how things are presented or imagined, things of the future are imagined. Now, This is just a very particular American way of thinking about the future. How can we break away from this? How can we re-envision the future? Because there must be other ways to think about the future than these kind of cliches. And in order to do that, in order to explore this, we set up the arts project Seeker with this Seeds Collective. And the Seeker project borrows from the Biomod project in this respect that it also uses a lot of recycled materials. And what we do in Seeker is actually we engage with local communities in a conversation on how a future starship could look like. And then we prototype such a spaceship using recycled materials. And this happens in all kinds of ways. So it's really a project which combines dialogue and hands-on prototyping. And some of the examples and some of the examples you can see here, for example, in the lower left, we bought a number of secondhand campers, caravans, and then we literally hacked the caravans. We cut them open, we split them into parts, and we built a sort of superstructure with those caravans, because caravans, of course, are, and especially in Europe, these type of caravans are an archetype of autonomous travel. And so the project really helps for communities to really think more deeply about how they think about these futures. Now, here is an example of some of the structures that we built. This was in the Z33 Museum in Belgium, a very extensive structure. We also designed the interior. It's not just for the looks of it. And you can already see, we don't always manage with the group to escape from some of the cliches that come from science fiction, of course. It's really, like I said, an open exploration. Now, this interior design is crucial for a reason that I'm going to talk about in a bit. And one of the components of the interior design is to think about these regenerative ecosystems that I talked about. And we always build a sort of simplified version of such a regenerative ecosystem in which we grow our own crops. We even grow edible insects that can then be eaten. And crucially for the project is that we run our own isolation missions inside the project. So at the end, when the project has been completed, we actually, with the people that actually designed it, we run a number of missions as a performance within the structure. So you have to imagine the resulting artwork is presenting in the museum, and then we live inside that structure without coming out. Everything has to be taken care of: sanitation, food, water, and we test what we built. And we also engage in conversations about future scenarios. So that's really the core of the artwork. Here. There's a second project I want to present here, and it basically it starts with an open question here. Like for many, I would ask, which place of the world is this? You know, what kind of landscape are we seeing here? And many people will be like, yeah, this looks like, you know, this could be the UK, I guess, somewhere in the United Kingdom, with the sheep and the hills and then the little bushes and everywhere. But this is actually New Zealand. And this brings up an interesting problem. We're talking about colonization here. And what you can see here is really one of the deep effects of colonization on our environment is the fact that colonizers often transform the landscape into the landscape where they came from. And when I talk to my Maori colleagues in New Zealand, these landscapes are actually alien for them. This is not something they recognize as native people. Sheep jumping around in this kind of British-looking landscapes is really something that was imposed onto New Zealand. And this brings me to this issue. And I'm just going to read this quote from Frida Knobloch from the 90s. The two words work together. Colonization is about enforcing land ownership through a new agricultural occupation of lands once used differently. Colonization brings culture to a wilderness. Colonization is an agricultural act. This is a very interesting connection between agriculture and colonization that sometimes we miss. Now, as I explained before, when we're talking about our humanity's deep future into space, we'll have to bring ecology. We'll have to bring agriculture. So there are particular aspects of bringing agriculture to deep space. And I have these very two sharp quotes that I want to read to you. The first one is from Valerie Olson. In extreme environments like outer space, the concept of environment cannot be bracketed out from life processes. As a result, investments of power and knowledge shift from life itself to the sites of interface among living things, technologies, and environments. The second quote is from Katerina Damjanov and Damien Crouch. In the unforgiving environment of outer space, the technological apparatus itself becomes not only a fundamental means, but also a central object of biopolitical governance. And this is really key when we're talking about the future of humanity in space. Basically, what it means is that every single molecule that you're going to breathe in air has to be produced by some apparatus somewhere around there. And who owns the apparatus owns life. It's very different than what we experience here. Nobody will claim oxygen here, right? We're just breathing. I mean, if we keep on destroying climate, maybe this is going to become a problem. But in space, it's very different. So suddenly, this is a radical shift for humanity, a radical shift in biopolitical governance. So we end up in this very interesting situation, where on one hand, when we look at history, we see this connection, this problematic connection between colonization and agriculture. And on the other hand, we are starting to colonize space and we are bringing agriculture into space. And if we don't properly start thinking about the ethics of all these, things might go wrong. And so that's where the space farming project comes from. That's the background of the space farming project, another project of the Seeds Collective. And the essence of the space farming project is basically to engage with local farmers that are non-space experts in this discussion. And this was a collaboration with multiple partners in Belgium with HOWEST and PTI. These are educational institutions in Belgium that are that are partially focusing on agriculture. And we basically engaged in this challenge. We developed 3 space farming prototypes, but they were built and conceived together with me, but they were non-space experts. Once again, this was an invitation to break away from established paradigms and to work with people that are not necessarily part of the field to see if we can come up with interesting suggestions here. And so I'm going to briefly run over the results of these 3 prototypes that were generated. This one is a photobioreactor and microgravity simulator. It's basically a cultivation system of small edible algae that are also used in the Melissa regenerative ecosystem that I talked about before. And what you can see in front is basically a microgravity simulator. The little tube that is mounted on that device is being moved in all kinds of directions all the way. And as such, the algae are in constant suspension, which is a kind of which simulates microgravity. These structures were presented as almost a kind of living sculpture. They even have a kind of modernist quality in the museum space. The second prototype that was built was this artificial gravity simulator. It's basically the opposite. Instead of simulating 0 gravity, this one simulates gravity because you could use this device in deep space. And by spinning the device, the plants, in this case, the lettuce growing in that structure, will experience a sort of pseudo gravity. And we developed it as an installation, once again, with very sculptural qualities. This was a beautiful piece that was also part of the installation. And then the last prototype, which I think is probably the most sophisticated of all of them, is called the plant morphogenerator. And in the plant morphogenerator, what we're actually doing is we are using callus tissue. Callus tissue is basically a clump of dedifferentiated plant cells that are ready to be transformed into a component of a crop depending on the plant hormones you give it. You can give it particular hormones so it will develop a lot of roots, but you can also give it other hormones so it starts to develop more leaves. So you can actually start tuning and tweaking the shape of the plant, and as such also the nutritional quality of the plant. So the idea is that you take these undifferentiated cells to space, and then using those plant hormones, you can drive the growth and the development of your plant depending on the nutritional needs. And that was a pretty interesting experiment that was happening live in the exhibition space. And then crucially, these 3 prototypes were surrounded by a graphic design piece. And the graphic design piece really displayed a whole range of images of colonization, the relationship between colonization and agriculture from ancient historical times all the way to utopian visions of the future, interspersed with some of these quotes that I showed you before. And this basically suddenly positioned those prototypes in a much more broader and critical perspective. Now, to conclude my talk, I want to talk a little bit about the imperative of arts and humanities in bringing forward civilization and rethinking our future. Remember the project that I just talked about, the Evolving Asteroid Starships project. There are multiple disciplines coming together in this project. And this is a cloud, and it's probably not even complete, of some of the main domains we are exploring in this project. And this is also typical for what we do with Seeds. Bringing together all these domains of engineering and science and art and design. This is almost, it's pretty confusing if you look at it this way, right? There's space architecture, there's computer simulation, there's installation art, audiovisual art, ecology, developmental biology, science fiction, etc. How does this all connect? You know, how to make sense of this? Well, I simplified it using this diagram. These are the 4 domains in which we're working. And we made a deliberate choice to work in all these fields. It's science, engineering, design, and art, because they all bring a particular sensitivity and a particular perspective to the conversation. And so what we essentially have is really those 4 domains that are not, it's not possible, it's not easy to create hard borders between those domains. You can see the dashed line, the porous borders between those domains. That's the first thing to observe in this diagram. These domains blend over into each other. And what the diagram really shows is the different ways in which these disciplines can interact. The first one is the level of multidisciplinarity. It's basically you tackle a problem from those 4 different fields, and then you bring the insights from those 4 different fields at the end of the research. You bring them together, put them together on the table, and that's the result. This is to me seems the least interesting approach. Interdisciplinarity is more interesting because then domains start communicating with each other. They start listening to each other, getting inspired by each other. They might use methodologies from each other. And so this dialogue starts up between those domains. I think this is already much more interesting, but what we are really passionate about and what we really think is crucial is transdisciplinarity. And it's been used quite a lot over the past 2 decades, I would say, but we have a particular view on this. First of all, we look at transdisciplinarity as a new dimension, a new zone of creativity. You bring in all these domains, and you allow people to contribute to those different domains, even though they might not be an expert in those domains. All opinions are really valued and investigated and used. And so, with a lot of serendipity, people start talking and experimenting with each other. It could be that an artist suddenly is interested in designing an ecosystem, an artificial ecosystem, or a computer programmer gets interested in the architecture of something and starts working with the architect, and et cetera, et cetera. And so you get this really almost like a metabolism of disciplines working with each other. And it's important to realize that the artist can really contribute to a scientific question or to an engineering question, specifically because artists have different sensitivities. So I think it's really crucial. And artists also have the capability of stepping outside of an established domain. I mean, that's what artists do all the time. That's what's demanded from them, that they take a step back, they look at things, and from a kind of avant-garde philosophy, they look at things that could happen but are not happening yet. And that's just one example in which all these domains can cross-fertilize. Now, crucially, in transdisciplinarity is that it's not like you're caught endlessly in this loop of serendipitous communication. It is still possible and worthwhile to step outside of that dimension of transdisciplinarity and to step back into more traditional domains. For example, what we do with Seeds is we tackle that problem of interstellar exploration through a radically transdisciplinary approach, but then we do produce scientific papers in computer simulation journals. And we do produce autonomous art installations that are exhibited in arts institutions. So, and I think it's that back and forth that really makes it interesting. So sometimes you step out, you bring out these more traditional forms, and then sometimes you're in the middle of that very fruitful, unpredictable cross-pollination between domains. So to conclude, I'm just going to give you a short wrap-up of the things that we talked about. The first one is molecular sustainability. Remember, there's different sensitivity on sustainability, which is more radical. It's thinking about molecules as a core element of our existence, and how this is typical for space, but also how this could be useful for Earth. Which brings us to the next stage of human civilization, which is post-planetary design, designing for a future where people live not just on the surface of Earth, something that is happening already, which brought us to the question of if we engage in thinking about post-planetary design, how capable are we? And can we change how to break through the paradigms that we run around with? And it brings us to the topic of futures literacy with a few examples on how we engage with our Seeds Collective. We engage with this, and we try to together with communities to think beyond some of the established ideas. Which finally brings me to how important it is to bring arts and humanities into the conversation when we're talking about building resilient and robust futures. Thank you.
Thanks, Angelo. That's really fantastic. I've seen many of these slides before, but I haven't actually gotten a chance to learn about the space farming project until today. So now we open the floor for questions, and I have a whole bunch of different platforms here at YouTube, UPOU Networks, and Facebook Live. And so if members of the audience can pose their questions, we will keep an eye out for them. In the meantime, I'll start the discussion by asking Angelo a couple of questions. And first, I suppose I'm going to try to summarize kind of two points that I got from this, and tell me if I get this right. And one of the points is about the importance of a country such as the Philippines to try to engage in thinking about the deep future. So if developing countries like the Philippines don't try to engage in imagining the deep future, in proposing visions for that far future, then only a very privileged few will get to shape that future.
Exactly.
Yeah. And the second is trying to figure out, where does art and where do the arts and the humanities fit in? And from this talk, what I'm getting is that art, including science fiction, which is a particularly popular genre in the Philippines. If you take a look at, say, Netflix, Netflix ratings of shows which are popular in the Philippines, that art and science fiction are possible ways to promote critical discussion and reflection on the kinds of agenda that scientific research pursues. Is that a fair summary of some of your points?
Yes, exactly. It's essentially what it does is, and of course, good science fiction always builds futures based on a small set of premises, right? You take in every science fiction story, you'll notice there's a few basic premises on how the world is organized, what technologies are available, and then it extrapolates from that. That's what good science fiction does in an interesting way. And I think this is the sort of capacity that probably we should teach students in a much deeper way. To take a few premises and then to properly extrapolate it and to try to break through the limitations of your imagination, which are often shaped by this very same science fiction. Now, when we're talking about science fiction, it's a broad term, of course. And what you can see, for example, in what you refer to a Netflix series, for example, or Amazon series like the one I showed, The Expanse, is that the range of possibilities in science fiction literature is way wider and more interesting than what we get to see on television or in the movie theater. And this has to do with the fact that the visual representation and the storytelling that happens in TV series and movie theaters is American dominated. So there is a very small cultural perspective on that. But in literature, you see a lot more freedom in exploring much more options.
We have an interesting question here. I'm going to rephrase this slightly from Harito on Facebook. Will there be capitalism in this paradigm? And I suppose the question is, so where does capitalism fit here in these futures?
The force of capitalism is very strong here. Let me start by saying that. This doesn't mean that I fully agree with that. It is a stage, and we're at a stage now where we are, how to put it, it's because of some of the positive forces of capitalism, because I'm not an anti-capitalist, but I'm definitely not a neoliberal capitalist. So I'm already bringing forward my political views here. But unfettered capitalism is definitely not something that I believe we should bring into space, because this is predatory by nature. And I think that's the least we could use. So ideally, we would have learned from our mistakes on Earth and not bring them to space. But then again, if I look at history, sometimes wonder if humans ever learn. And what we can already see through forces like Jeff Bezos and Elon Musk is that capitalism is very much part of the conversation. It's shaping the conversation very much right now, which is quite problematic. And one of the more problematic statements that's been made by Elon Musk recently, and I'm paraphrasing here because I don't know the exact way he put it, but he was like, if I'm going to build a city on Mars, no country or institution has any say in this. We will run that place because it's our place. We built it, we did it. I'm not going to deal with all the, some kind of United Nations oversight or whatever oversight. It's our place and we run it. It would basically be a society that would be fully corporate. It would be a corporate run world, which is something we know from science fiction dystopia. And I'm not sure that's the best idea. So I think there are a lot of reasons to be concerned, because it's already happening with people, like I said, like Jeff Bezos and Elon Musk. But on the other hand, it's not too late to start putting a number of things in place to avoid a runaway predatory capitalism expanding in space. So a second thing that I want to bring to this particular conversation is, it's not just that it's already happening and we have to be careful, but that it will have tremendous impact on life back on Earth. And this, I'm specifically thinking about asteroid mining, of course, something that I'm also working on. Some asteroids, and you might have seen this in the news, contain so many minerals that they would create absolute unimaginable fortunes for the person that would actually manage to technically mine those asteroids. So what's going to happen is, on one hand, you might destabilize some of the markets on Earth because you're bringing so much of these rare materials to the Earth's surface. Secondly, you might generate corporations that have wealth that overshadows the biggest corporations of today, and that actually overshadow a lot of countries on Earth. You will have these extraterrestrial economic entities with a vast wealth that overshadows most of Earth. You can imagine the political consequences of that. So we are going for some interesting times in terms of that.
Thanks, Angelo. Before I move on to the next question, I just wanted to point out to anyone who doesn't know yet, but the Philippines actually has a Philippine Space Agency. It was recently established. And just a couple of months ago, they were actually hiring. And so I think what's going on in terms of Philippine space research and activities is quite interesting. But let me move on to a question from the audience. Here's one. Designing with uncertain futures is very relevant in the education sector. Are there techniques that you could suggest to be applicable in designing the curriculum or designing curricula of the future?
I think pushing your imagination into unusual or uncomfortable context is a good one. I always use the example with Seeker, one of the projects that I presented, the spaceship that we prototype and that we test by running these isolation missions inside of it. And the example I'm always bringing up in terms of education is if you approach a group of students and you're like, let's reimagine the house of the future. Well, you'll get a little bit of enthusiasm, but it's not the coolest thing. But if you ask that same group of people, let's build a starship, let's just go for it. It doesn't matter. None of us is an aerospace engineer. Let's nevertheless address as much of the challenge we can. You get a whole different kind of energy and of creativity in that group. So really framing the kind of scenario that you're imagining and you're proposing that people have to mentally inhabit is really crucial here. Secondly, as a technique, and I think Diego and me will both agree with this because we've been building a lot of experience with this, combining hands-on experimentation with critical reflection is really a game changer. We've built Biomod, we've built Seeker versions, and just engaging with that physical reality just changes your insights in your conversation. If you're coming together with a group and you're just strictly theoretically thinking about a space architecture in which people have to live in an extremely sustainable way, or you bring a lot of recycled materials and people have to physically start constructing things, their thinking changes radically. It's just because that's how it works. I think we can all relate to that. So I think that's one of the ways in which you can move that education forward.
That's a nice segue to the next question from Raymond Salbai, and who thanks you for a very interesting, enlightening talk. And he's wondering about the social dimensions of post-planetary contexts. Do you have examples for how humans might interact with each other in such imagined futures? Well, I suppose the question is, will it be different in any sort of way?
Yeah. This is once again a topic that is of course explored in a lot of science fiction series, both books, movies, and games. And it all boils down to this, and this is really a challenge for humanity right now. It looks as if currently we are developing civilization outside of space, not just as a thought, but it's actually in full swing. We're going back to the moon. Commercial companies are building all kinds of plans to bring things to the moon and to Mars. There's talk about space hotels. So there's really this very exciting and very new layer of human civilization that is in development right now. I lost my train of thoughts. Can you repeat the question?
So what will human interactions be?
Yes. The social aspect. Yes, I was like, yes, the social aspect. The thing is, the conversation as we're having it now, the global conversation, is still dominated by a few actors, let's put it this way. And there are already quite a bit of established paradigms in space exploration. I've been using this over and over again, this idea of entrenched paradigms. And I think it's important that we start trying to open up the conversation on how our future in space could look like by engaging the whole world and all kinds of cultures. What would a Filipino space station look like if it's not designed along NASA lines, Because of course we all admire NASA, but let's step away from it and let's go back to some Filipino core values on how people should socially interact. Maybe there is some technologies or ideas on how to live sustainably that we can learn from the Philippines, and how would that translate into a Filipino space station, for example, right? So that's one way of the thing. So on one hand, it's really important to bring that inclusiveness and diversity into space. On the other hand, what might happen in space is divergence. And it means that basically these different cultures slowly, and this is of course inherent to evolution, will start to move away from each other, socially, emotionally, culturally, because there will be different cultures establishing itself on the moon and establishing itself on Mars. For example, in 100 years, it's possible that in the Philippines, you can not only go to a French bakery, but you can also go to a Martian restaurant, because that's where they serve dishes that are actually invented and created on Mars. And it's a cuisine now, and it's one of the options. As cuisines from outside of the Philippines or here in Europe, the same thing. And so that divergence, of course, is also risky. This can create conflict. And once again, this is one of the topics that is explored in the series The Expanse. But of course, there are many other examples of that.
I'd like to follow on from the earlier question about training and education. And I'd like to frame this in the context of one of the ways that innovation is typically talked about. Have you heard of the cat, pig, frog model? So in terms of pushing the boundaries of any kind of innovation, you copy first. So you're a copycat, and then you piggyback, and then you leapfrog over an existing technology or innovation. And it this kind of assumes that there is a single path forward, or there's kind of a linear way forward. And I'm using this to frame the question around training for pluridisciplinarity, whether it's multidisciplinary or interdisciplinary or transdisciplinary training. Do you think that there is necessarily a phase in which there needs to be specialization first? And whether that's, as an individual, you need to really train to become a really good computer scientist first, or a really good artist first? Or is there any merit to current transdisciplinary programs that you see now that are emerging, say in undergraduate studies, where from at the get-go, students are being trained in a variety of different fields? And one of the questions, and I suppose I'm asking this from the perspective of leading a program here at the UPOU that is supposedly interdisciplinary, the Multimedia Studies program, should we be focusing on one discipline at a time before trying to move on to the others? Because every time we have talked about interdisciplinary training in the Philippines, this is often a response that we get from educators or students.
That's a good point, and I actually haven't really touched upon it in my talk. So it's thanks for bringing that opportunity here. My personal experience, and this is really based on my personal experience, is that if you only focus on multidisciplinarity or transdisciplinarity, it might not be enough. In my personal path was basically first studying biology. I'm a developmental biologist and an ecologist. First, that was my initial study. So I have gone down the path of biology and working, in the field of in a science field, publishing, doing the whole thing that is typically for a science practice. On the other hand, I also studied photography in an art school. So I've walked down that path, going really deep into the world of photography, even, working in London with a photographer that mentored me for some time. So I had both in arts and in science, I really built up that experience of going really deep into one particular domain. Now, I am still exhibiting photos, but photography is not my main artistic medium any longer. I've expanded into installation art and more socially engaged art. But having that deep experience with at least one field within art and science really made it more easy to pick up new knowledge and also to understand the internal logic of science, for example. I mean, imagine you get a science training, but you only superficially get a little bit of introductions from everything, but nothing deep. Well, it's going to be really hard to really fully realize what the practice of science means. And the same thing with the arts. So I am actually really I'm a proponent of both, that you need to choose one somewhere and go deep. You need some depth, but at the same time, for people that are interested in this, and only those, to learn to think in a more transdisciplinary way and to let go of preoccupations and to step out of your comfort zone and to find the confidence to pick up other fields and to really work on both simultaneously. But once again, this really depends on the personality. And that's something we should not forget. Some people are really, really good at specializing, and we need those specialists. It's all about bringing them into a culture of transdisciplinarity and making them at home and engaging them in the conversation. And then some people are craving for multiple explorations. And I think I always compare it to that one question that kids get over and over again. So, young man or young lady, what do you want to become later when you're grown up? It already starts there. Things already start going wrong there. Kids are already forced to make up their mind and to choose one single thing. they will never answer, well, I would like to be both a biologist and then a space systems researcher and probably a community artist and probably a photographer at the same time. But that's what I became because I was always interested in those things, and I could never answer that question because I have multiple things. And so when we see that quality in people, that drive in people, we should nurture it. But when they have a different drive, which is more in the direction of specialization, we should also honor that. So it's really about, tapping into the potential of people.
I have 2 more questions from Facebook Live. The first is from Romel Nuestro. How far in the future would this be, having an interplanetary spaceship and colonizing the moon and Mars? So what's your ETA on this?
Yeah, there are different ETAs, of course. The moon is, is relatively close. We need to see what's going to happen with the new American administration, if they're still going to support going back to the moon as much as the previous administration. But there are other countries that are really focusing on going to the moon, not in the least China, for example. And there's a whole commercial program that has been built up to go back to the moon. So the moon is going to be very busy between now and 10 years, and probably to stay. Not like the Apollo program, where it was basically about getting there and showing off and then coming back to Earth, and that was it. Now there's going to be much more of a more established presence. And the idea is the moon can serve as a test ground for multiple technologies that can bring us deeper into space. Mars is a difficult one. I've mentioned his name a number of times. Elon Musk is, of course, promoting the idea that in a number of years, he'll be sending hundreds of people with Starship all the way to Mars. I think you need to take a huge grain of salt when you're listening to these stories. It's beautiful storytelling, but it's not very real. And one of the issues that you can see is that it's not because you're active in the field of rocket launches that you know how to set up a crewed deep space mission. A crewed deep space mission is something more than just building a vehicle that can contain people and launch them away from Earth. We're talking about the medical and psychological aspects of long-term voyages. And honestly, we don't really know what happens to the human body when it's exposed to deep space radiation over such a long period of time. And just skipping that question and just putting people in a rocket and hoping that they will arrive on Mars is not really a smart way forward. So Mars, even though there are very optimistic sounds in the media, it might indeed still take 30 years. And then going outside of those inner planet regions and starting to explore the outer reaches of the solar system, well, that might take another 100 years. And interstellar exploration, well, I'm guessing might also at least, maybe 100, 200, 300 years from now. But the reason that I'm interested in interstellar exploration is that it enables me, once again, to rethink things in a fresh way. And the ideas of morphogenetic engineering that I showed, like a structure that develops itself instead of top-down design, is of course something that we can also apply to contemporary space exploration. That's something that I forgot to mention. It's not just speculative.
We have another education question here from Jean, and I'm going to read it out loud and then ask and see whether. Sorry, I just lost that question. Sorry, I just lost that comment. Where did that go? But if I can rephrase what I did see earlier, right now there are standards for how to teach and how to learn, and things are becoming more standardized. I guess that as a way to level up education in the country in a uniform way. But this kind of standardization seems to run counter to the kind of a diversity of learning approaches. Do you have a comment on this?
We need the rebels, we need the hackers, and we need the artists to break away from traditions that might not be the best way forward. So I think it's all about, how to put it, it all boils down to fear in the end. It's fear from administrators and politicians to make the wrong calls and the wrong choices. But I think if we would allow for a educational and policy and a climate in which we're allowed to set up small-scale experiments and then actually actively extract lessons from that that can level up and be deployed on a larger scale. I think that would be an interesting approach. But this has to be nurtured and maintained. It's not because you set up some small-scale interesting experiments that this will eventually, seep down in much higher level thinking of how to move forward as a country. So I think it really needs an active policy, but it also needs some courage. And of course, you need to give away some of the agency to other people. I mean, I can imagine that, for example, as a legislator, politician, educator, some of these methodologies are a little unusual for you, but then you can just ask other people to help you out, and you just need to trust. You need to trust that path forward. The thing is, mostly you can experiment as much as you want, and you can try to innovate as much as you want. And it always reminds me of the same thing that I've experienced many times. If you don't fully extract and structure the lessons learned and then level them up, it's a waste of time and it's just a PR stunt. And I've participated in quite a number of brainstorming sessions and creative sessions where typically we would work with Post-its, the eternal Post-it, to craft all these imaginary futures and solutions. And then the workshop is over and the Post-its are basically trashed. And that was it. Thank you very much for your contribution. This was a creative afternoon, and that was it. And then I'm like, what's the point of this? We can keep on doing this over and over again. So it's really making a pipeline between the potential of all these creative people that really want to rethink things and then the higher levels of governance. And just, building trust.
Okay, just for completeness sake, because I finally did locate the question, it's from Jean, who asks, educational designs primarily on research studies are getting entirely different in the future, considering that research and innovations dictate the universal frame of learning. So I've just read that out loud, but I think, I'm not sure whether I had rephrased your question appropriately.
Mm-hmm. There's another question here in the chat box about educational designs.
Yeah, that was it. So I just I read that out loud verbatim.
Yeah, because that's the one, right?
Okay. I think, I have just a couple more questions, unless there are any more coming from Facebook Live or from the UPOU network, from YouTube. And I guess it boils down to being more practical. So I've, over the course of living in the Philippines and teaching here, I have met people who seem to be looking for a kind of community that is interested in precisely these kinds of issues, speculative futures and art and technology and design. How do they get involved, Angela, in these conversations? For example, with the Seeds network, is there like
Yes, that's something actually I didn't clearly mention during my talk. But so Seeds is this international transdisciplinary collective of artists, scientists, engineers, activists, all working together on a series of projects that keeps expanding. But relatively recently, we started creating chapters. And so we have, for example, we have a chapter in UK, but we also have a chapter in the Philippines. And that was the email address that you could see on my last slide. And the idea is really that in the Philippines, we will have this platform in which all these different people with these different backgrounds can come together to actively think about and prototype alternative visions for the future and really combine arts and humanities with the domains of science and engineering. And so if you're in the Philippines and you're interested in this kind of explorations, you can get in touch with the Filipino chapter.
Yeah, there's I think you flashed an email address right at the end of your talk or at the beginning of your talk,
it's
right?
Philippines@seeds.network, and Seeds is written as SEADS. So Philippines@seeds.network.
I think that's all we have for now in terms of question, Angela. Thank you very much for your time and for sharing your expertise.
You're most welcome.
I'm going to hand this over back to Jessica. Jessica?
Okay, Thank you so much, Dr. Vermeulen and Dr. Maranan, for such very interesting discussion about today's topic. And also, we want to thank you for all the viewers who sent their questions. Thank you so much. And Dr. Vermeulen is really, I learned a lot about the planetary design, reimagining paradigms of the future. Very interesting. And if we could grab a hold of your keynote. But yeah, thank you so much for all the information you've shared with us this today. Again, I would like to remind everyone that we are issuing e-certificates of participation. Just make sure to answer the evaluation form of this webinar. And just a few reminders about our evaluation. It will be available after this webinar. So there you can see the link and also the QR code. Kindly screenshot it and scan the QR code because this will be available after the webinar. And another reminder, it will only be available for 1 hour after this webinar. Okay, so that's all for our reminders. Now, to officially close this webinar and to give us a synthesis of the topic discussed, I would like to call on Dr. Myra Oruga, Assistant to the Vice Chancellor for Research and Publications. Ms. Myra?
Yeah, thank you, Jessica. In behalf of UPOU, Office of the Vice Chancellor for Academic Affairs, in collaboration with the Faculty of Information and Communication Studies, our VCAA, Dr. Melinda Lumanta, Chancellor Melinda Bandalaria, VC for Finance, Dr. Jean Saludades, the Dean of FICS, Dr. Alexander Flor, Director Lisa Helisan of Multimedia Center, Office of the Public Affairs, Dr. Joanne Serrano, the other deans of our faculty of Dr. Primo Garcia of FMDS, and the Dean of Faculty of Education, Dr. Bagarinaw, our two moderators, Jessica and Dr. Diego Maranan. I am Dr. Mayruga, would like to thank our speaker, Dr. Angelo, for sharing with us a very interesting topic of post-planetary design, reimagining paradigms of the future. Okay, may I just share with you some of the points that I have captured during his talk? Okay, what struck me is the word seeds, space, ecologies, arts, and design, combined approach of hands-on experimentation and theoretical reflection. The words decolonizing imagination, uh, hacking, if I correctly he heard it, emergence, the word emergence. He also presented several works such as the COVID-19 tech. I saw it in his presentation. The haplos, Dr. Diego showed that to us. He even presented that to us, if I remember right. Oratory, biomode, among others. He said that they are a group of transdisciplinary group, how they operationalize diversity as a co-creation. I remember UPOU, the word co-creation, the values, valuing people's input, okay? The Biomod project. He also presented 4 domains, I think: molecular sustainability, post-planetary design, futures literacy, and the imperative of arts and humanities. And he mentioned some of the examples and explained to us very in detail these 4 concepts. When Dr. Angelo is lecturing or saying his explanation, I cannot help but imagine Avengers. What's that? Star Wars. Those are the things that comes into my mind. Okay, because this is a new approach. I am into public health, but this is a new methodological approach to me. Uh, okay, so he also mentioned modeling formalism, agent-based modeling, the dev system dynamics, evolutionary algorithms. What struck me also is the futures literacy, the approach of engaging community and explaining their works, okay? Because in public health, we do that most of the time, community engagement. The space architecture, system engineering, the association of space biology, science, arts, engineering, and and cross-pollination of that domains. The space farming, okay, that struck me also. So again, I would like to thank you, Dr. Angelo, and to all those who attended our series, future webinar series. I'd like to thank all of you. This is our last webinar for this year, and hopefully we can organize again next year interesting topics we can share to all of our viewers for free. Again, thank you very much. Maraming salamat po. And good afternoon to everyone.
Thank you.
Hey, wait, are we done? Yay!
Okay.
Thank you, Angela.
Very good.
Thank you, Jessica, Myra, Lisa.
I needed to warm up. In the beginning, I was really not as sharp as I used to be. But anyway, I hope that didn't show too much.
It is 9 a.m. No, absolutely not.
Okay.